Now, I mentioned earlier that geologists distinguish among different kinds of faults based on the nature of the slip that takes place on a fault. Now, let's imagine that we've got an intact block. Let's imagine now that that rock has been broken by a fault. It's not perfectly vertical, it's not perfectly horizontal, but this particular fault has a slope. Now, if the displacement takes place so that this block above the fault moves down relative to the rock below the fault, then we end up with a geometry like this, and we can show the sense of displacement by these half arrows. That's the fault scarp right there. Now, when we have this kind of displacement, where the rock above the fault, which geologists refer to as the hanging wall, moves down relative to the rock below the fault, which geologists refer to as the footwall. So in this case, the hanging wall has moved down relative to the footwall. Geologists refer to this kind of fault as a normal fault. Now you might wonder, why do you call it a normal fault? What's normal about it? Well, there's nothing normal about it. It just so happens that when faults were first recognized and identified, the place where that happened to be was a place where most faults had this kind of geometry. And so the people working there called them normal faults. But there's really nothing normal. It's a very unfortunate term, but it's now ingrained in the literature, and we're stuck with it. Now, let's imagine that instead of this geometry, the opposite happened. This time, we're going to take the hanging wall and move it up. In this case, the hanging wall has moved up relative to the footwall. This is called a reverse fault. So we have normal faults where the hanging wall moves down. We have reverse faults where the hanging wall moves up. Now, if you look at what's happening to this block as it goes from this configuration originally to this configuration or to this configuration, the change in length of this block of rock is different. Geologists refer to squeezing as compression and stretching as tension. Compression and tension are types of stresses. We depict compression typically by arrows pointing towards each other and tension by arrows pointing away from each other. Stress can change the shape of rocks. Specifically, compression causes shortening, a decrease in length, whereas tension causes extension or lengthening. So my point in explaining those details is to emphasize that faulting doesn't just generate vibrations geologically, it also changes the nature of the crust. It can stretch crust, it can shorten crust. Let's imagine a simple situation depicted in this simple diagram. Here we have a marker layer that has been offset by a fault. So when we start our view, the fault is a pre-existing structure. It already exists. Now imagine that this region is subjected to compressive stress. Over time, the compression may become big enough that eventually it overcomes the asperities that have locked the fault in place. And suddenly the fault slips. Well, when that slip occurs, the fault may grow a little bit, so there may be new rock that's breaking at its tip, but also the pre-existing part of the fault undergoes slip. And in this case, that results in further displacement of the red marker bed. So we've seen that faults can either initiate in intact rock or can slip again once they already exist. And both of these situations lead to the development of an earthquake. What about when things slide sideways? Faults on which a piece of the Earth's crust, which is the outer layer, we'll get to that later, places where a piece of the Earth crust slides sideways relative to another piece are called strike-slip faults. Let's imagine that we've got a block, and then we shear it, meaning that we take one side and move it relative to the other. At some later time, we can have this geometry, or we can have this geometry. Both of these are examples of what geologists refer to as strike-slip faults. Now, in this case, if I'm standing on this side of the fault and I'm looking that direction, this block moved to my left. So this is called left lateral. And if I'm standing on the same side of the fault and I'm looking this way, the block slides to the right, it's called right lateral. We will be using these terms later on when we're describing particular faults that occur on the planet. So these are just useful adjectives for describing faults.